Today we are going to take a lecture on GTU paper solution of BE Sem 1 or Sem 2 June-July 2011. I am Hardik Maru, having the designation of Assistant Professor at Engineering College, Junagadh. So let us move on to the GTU paper solution for BE Sem 1 or Sem 2 examination June-July 2011, Hardik Maru, Engineering College. Let us move to the first slide. This is the first question on the slide which we are going to solve for engineering physics. In engineering physics, mostly all of the questions, the first question which is asked is differentiate loudness and intensity of sound. Explain Weber-Fechner's law. This question is mostly asked in near about 6 marks or 4 marks. Let us go or move towards the answer. This is the differentiate between the loudness and intensity of sound. The first difference between the loudness and intensity is it is just an aural sensation and it is a physiological phenomena rather than the physical one. That is, loudness is the degree of sensation, whereas if we go towards the intensity is the quantity of energy propagating through a unit area in unit time per unit time in the direction which is normal to the direction of propagation. Let us go to the second point. It refers to the internal or subjective aspect, whereas intensity refers to the external or the objective measurements. We can say that loudness is merely a degree of sensation produced on human ear, whereas it is a physiological quantity, that means the quantity which relates with the human being. Whereas if we talk about intensity, it is a physical quantity. The unit to measure loudness is shown, whereas the unit to measure intensity is watt per meter square. That is the quantity of energy which is flowing through unit cross section area per unit time. So this was the first question which can be asked, that is the difference between the loudness and intensity. Now let us move towards the next slide which explains the Weber-Fechner's law. Loudness is the degree of sensation produced on the ear. It depends on intensity and also upon the sensitiveness of the ear. Loudness is directly proportional to the logarithm of intensity and it is known as Weber-Fechner's law. My dear friends, this is the Weber-Fechner's law where there is a relation between loudness and intensity. Loudness is directly proportional to the logarithm of intensity. Let us move towards the relation on the next slide. Here you can see that L represents the loudness which is directly proportional to the logarithm of intensity. That means loudness represented by L and intensity is represented by I with the multiplication of log base 10, that is logarithmic intensity. L is proportional to log base 10 I. If we take out the proportionality sign, there will be a proportionality constant which is called K, where L is equal to K log base 10 I. K is the proportionality constant which can be practically taken, which is equal to 1. Now if we differentiate the loudness with respect to intensity, that is dL upon di, on the right hand side of the equation K is constant, whereas log base 10 I, if we differentiate it with intensity, it will become 1 upon I. that is dl upon di is equal to k upon I. dl upon di is the sensitiveness of the ear. That means dl upon di according to the equation is inversely proportional to intensity. So accordingly we can say that dl upon di is called the sensitiveness of the ear. dl upon di is represented as sensitiveness of the ear. So we can say that sensitiveness decreases with increase in intensity. As I said, intensity is the inversely proportional to dl upon di, that is the sensitiveness. So if intensity increases, the sensitiveness decreases. This was the first question which can be asked for 6 marks, where the difference between loudness and intensity is asked, and with respect to that the Weber-Fechner's law can be asked. So this much is the proportion of the answer which should be written during the examination. Now let us move towards the next question, which is in question number 1. Question number 1 B. Here this question is asked in 4 marks. There is a comparison between hard and soft superconductors. This is the second question, question 1b, which is asked as hard and soft superconductors. This is the comparison between hard and soft superconductors. Actually, soft superconductors is also known as type 1 superconductors, and hard superconductors is also known as type 2 superconductors. Here it could be also asked as compare type 1 and type 2 superconductors, which is for 4 marks. So this is the answer for the question. As you can see in the slide, the comparison between soft superconductors and hard superconductors, the first point is soft superconductors are those which can tolerate impurities without affecting the superconducting properties, whereas the second point on the hard superconductor is hard superconductors are those which cannot tolerate impurities, that is, the impurity affects the superconducting property. According to the soft superconductor properties, they have low critical field values. That means we can also say that the type 1 superconductors have 1 critical field values, whereas going on the hard superconductors or comparing it with hard superconductors, they have high critical field values. That means if a particular critical field is applied on a soft superconductor or type 1 superconductors, it could be easily converted to superconducting from a superconducting state to normal state, whereas it could be converted from normal state to superconducting state. But to achieve a normal state in type 2 or hard superconductors, it needs a higher critical field values. That means we can say that hard superconductors type 2 have high critical field values. Now we can say that soft superconductors shows or represents complete Mechner effect, whereas hard superconductors are not showing the complete Mechner effect. In this slide there is one more example, that is the example of superconductors, that is soft superconductor and hard superconductor. Tin and aluminium are one of the example of soft superconductors, whereas niobium is one of the example of hard superconductors. So this was the question which could be asked for nearly about 4 marks. This is the simplest comparison between hard superconductors and soft superconductors. For 4 marks you can write near about 4 points to compare hard and soft superconductors or type 1 and type 2 superconductors. Now let us move towards the next question, which could be easily asked in your examination. The next question, that is 1C, which is asked in 4 marks. This question is asked from the topic or chapter laser. State the properties of laser. This question is also asked for 4 marks. Laser is light amplification by the stimulated emission of radiation. I repeat, laser is light amplification by the stimulated emission of radiation. Here you can see that there are 4 properties which are given for laser. The first property is coherence, the second property is high intensity, then high directionality, and then high monochromaticity. I repeat, the properties, these are the 4 properties of laser. One is coherence, high intensity, high directionality, high monochromaticity. Now let us define, or let us know how these are the properties of laser, or according to this property how laser will behave. Let us move towards the first property and towards the next slide, that is coherence. Here in the slide you can see that the first point, coherence. What do you mean by coherence? The wave trains or a wave which are identical. Identical means same. The wave trains which are identical in phase and in direction are called coherent waves. That means those waves which are having same phase as well as same direction are called coherent waves. Since all the constituent photons of laser beam possesses the same energy, momentum, and propagates in the same direction, the beam is said to be coherent. That means those beam which are coherent, their photon constitutes same energy, same momentum, and propagates in the same direction. It doesn't scatter. That means this is the first property of coherence. Let us move towards the next property. In this slide you can see that this is a coherence. From a normal light which is scattering, when it is converted to laser, the waves which are coming out through the laser are the coherent, are having the properties of coherence. That means they are identical in phase and they are in same direction. They are traveling in same direction. The second property is high intensity. Due to coherent nature of laser, it has the ability to focus over a small area of 10⁻⁻⁶ centimeter square. That means if the wave is coherent, that means it is having identical phase and same direction, it has the ability to focus over a small area in comparison to normal light. That means if it is focusing on a small area, that is the smallest area of 10⁻⁶ centimeter square, it is having very high intensity on the smallest focused area, extremely high concentration of its energy over a very small area. So this is one of the property, that is the second property of laser, that is high intensity. Let us move towards the third property. An ordinary source emits lights in all possible directions, that is high directional. If I am comparing the laser with normal light, or if I say sunlight, or if an ordinary light, then ordinary light or a sunlight scatters in all possible direction. But if I say laser, then laser propagates in a particular direction. That means laser is directional. Laser light is directional. An ordinary source light emits its light in all possible directions, since laser travel as a parallel beam and it can travel over a long distance without spreading. That means if ordinary light scatters, it cannot travel over a long distance. But due to the coherence nature, due to the focusing nature, the light of laser becomes directional and it can travel over a long distance without spreading. As I said, normal light spreads more and cannot travel a longer distance. In comparison to that, the angular spread of laser beam is 1 millimeter per meter. That is very small. Now let us move towards the next property, and before that let us see what is the difference between ordinary light and what is the directional property of a laser light. In our slide we have some photos through which you can see that what is the difference between the directional light, which is focused, and ordinary light. Here you can see in the photo a sunlight, and sunlight scatters in all possible direction. This is the photograph of a sunlight which is scattering on all possible direction, whereas let us move towards the next slide. Here this is the photograph of a laser which is getting concentrated or focused on a small area. That means it is having a coherence nature as well as it is traveling in a form of a beam and can travel over a long distance. That is what you call a directional beam. Now we are going to the next property, that is high monochromaticity. From a normal monochromatic source spreads over a 100 nanometer wavelength range. The form of a normal monochromatic source spreads over a 100 nanometer wavelength range. Whereas laser is having a single wavelength, that means it spreads the spread of that light is of the order of 1 nanometer and it can emit light of a single wavelength. That means